talked about so far. We're still talking about lateral area, surface area, and volume of our solids. Today we're going to compare similar solids and talk about their scale factors, perimeter ratios, area ratios, and today we'll also be adding on volume ratios since we now know how to find volume of our 3D figures. So first we have our scale factor. Remember, your scale factor is just the ratio of the lengths of two corresponding sides of two similar polygons. Remember, your scale factor can also be referred to as a similarity ratio. That would be the same thing. All right. Then we have our perimeter ratio. Remember, your perimeter ratio is supposed to be the same as your scale factor or your similarity ratio as far as the numbers go, right? But this is the ratio of the perimeters of two similar polygons. Alright, and then we have our area ratio, which is the ratio of the areas of two similar polygons. And what do you have to do to a perimeter ratio or a scale factor to turn it into an area ratio? Very good. So if I was given some perimeter ratio, you can add this below. Maybe they just said the ratio was A over B. Then if they asked me to turn that into an area ratio, then I'm going to need to square both A and B. So it end up as A squared over B squared, right? And that's what we learned back in Unit 8 when we were just talking about our two-dimensional figures. Okay? So it asks for the chart below, are the following solids similar? How do you know? And then if we say that they are, they want the similarity ratio and the area ratio between the figures. Okay, so remember, whenever we're coming up with ratios for the side lengths, it has to be for corresponding sides, right? So what side corresponds with this one in the second figure? This. Okay? So if I was setting up a scale factor or a similarity ratio, for those sides it would be 3 over 6, right? Okay, what about for this side right here? 4. Well, if these two figures are similar, shouldn't their sides ratios be the same? And are these two things congruent or equal? No. And I could take it one step further to prove that over here, they're 2 over 6, which is still not equal to these, right? So would we say that these two things are similar? No. So these are not similar. And when it asked for the y, well, we just proved it right here. We proved that none of their corresponding sides had the same ratios. Okay, let's look at figure B. On figure B, which side corresponds with the 3 in the larger figure? 6, okay. So 3 over 6. Okay, and then what would correspond with the 2 here? 3. And is 3 over 6 equivalent to 2 over 3? No. So are these two figures similar? Alright. So then let's look at figure C. We're looking at corresponding pieces. What corresponds with the 6 in the smaller figure? 5, so I could write it as 6 over 5. Okay, and what corresponds with the height of 12? And is 6 over 5 equivalent to 12 over 10? Yes. So I could say that yes, these ones are similar. Okay, because I said they're similar, they asked us to fill in the next 2 blanks as well. They asked what is the similarity ratio? So our similarity ratio would be what? 6 over 5. Or remember, you can also write that as 6 to 5, like that. Either way is fine. Okay, then they asked for the area ratio. What am I going to do to get the area ratio? Squared. So I would have 6 squared over 5 squared, which is really what? Very good. Okay, so in order for 2 figures to be considered similar, their corresponding sides have to have the same ratio. Okay? All right. So then if you will flip it over onto the back. Okay, example 2 here. They ask us for all this information of this figure. You can see that they shaded one of the sides here, so that's the side they want you to consider as your base. Okay? So when they ask for P, what does P mean they want? Perimeter of the what? Base. So that would be the perimeter of this shaded one over here. So what would be the perimeter of that? 28. Very good. Okay? And B, what does capital B mean they want? Area of the base, and what's the area of that shaded side there? 48. Okay? Then they ask for lateral area. Well, this is a prism, so how do you find lateral area of a prism? Perimeter times height. Okay, and we said the perimeter was what? Okay, and the height has to be what to your base? Perpendicular, right. So what is the only line that's perpendicular to my base? The 10. Right, it's opposite. It's going to hit that side like this, forming a 90-degree angle. So there's my height. So what is our lateral area? Okay. Then they want the surface area. How do you find surface area? Good. Okay. And we already said that the area of the base was what? 48. So what would 2 times 48 be? 96. Plus perimeter times height, which we already said was. So what's our surface area going to be? 376. Alright, and then lastly, how do we find the volume of a prism? And we said that the base area was. And we said the height of this thing was, so the volume must be good. Okay, so we found all this information. Then in this chart below, it says now you're going to double each of the sides. So I've still got the same type of shape, but the measurements are going to change. Okay? I guess I should put the of this piece being 10, what's it going to be if I double it? And instead of this side being 8, it's going to be, and instead of this side being 6, it will be good. Okay, so for my new perimeter, if this is still being considered the base, what is our new perimeter going to be? Good. And the old was 28. Okay. Then they want the new base area. What would our new base area be for that shaded side? 192. And originally it was good. Okay, then they want the lateral area. So lateral area is perimeter, which we said was 56 times the new height, which is 20. So what is 56 times 20 going to give us? Good. And then the original was 280. Okay, then we have surface area, which was 2 base areas, so 192 times 2, plus that lateral area. And then the original was 376. Okay, and then lastly we have our volume. So the new base area, 192, times the new height of 20 is going to give us a volume of, good, compared to the old, which was 480. Okay, so now we have the chart filled in. Now they ask us to answer a couple questions about what we found. So it says, since we doubled the side lengths, the similarity ratio, or scale factor, is now 2 to 1. So the perimeters of the base for us would be 56 over 28. And will that simplify to what? 2 to 1. Which makes sense because we said our similarity ratio and our perimeter ratio should always be right. Okay. Then they want us to compare the areas of the bases. Well, our new base area was 192. Our original base area was 48. Will 192 over 48 simplify to what? 4 over 1. And what did we say you had to do to a perimeter ratio to turn it into an area ratio?
Square.
And 2 squared is 4, 1 squared is 1. Okay? Then for our lateral areas, we had 1,120 over 280, and will that simplify to what? Which makes sense because lateral area is still a type of area, right? Okay, then for our surface areas, we've got 1,504 over 376. Will that simplify to what? So again, still a type of area, so still has that same area ratio. Lastly, they ask us to compare the volume. So 3,840 over 480. What does that one simplify to? Good. All right, so we haven't really talked about volume ratios yet. But they do ask us to make a conjecture about what we have decided is going to be true for our perimeter ratios, any of our area ratios, and now our volume ratio. Okay, so first, the ratio of the lengths. It says if your ratio is A over B, then what would be the ratio of your lengths? Should it be any different? So it should still be A over B. Okay, what about your ratio of perimeters or circumference if your figure is round? Still the same, very good. What about the ratios of your areas, whether that's base area, lateral area, surface area? What's going to be true about that? Very good. lastly, now that we got one up here that we simplified to 8 over 1, while area was 4 over 1 and perimeter was 2 over 1, what do you guys think our rule will be for ratio of volumes? Very good. Which would hold true, right? If I go back up here and look, what is 2 cubed? 8. And 1 cubed would still just be 1. All right. So now we have our rules. So they ask, when would I use the ratio of the links? Well, we would use them if we were either looking for a missing side, right, to set up our proportion, or if we were trying to find maybe a perimeter, right, for a smaller or larger figure that's similar. So when looking for missing side or perimeter of similar figures. Remember, you can use this symbol to represent similar. Okay? Okay, next question says, when would we want to use the ratio of areas? Well, same scenario, right? Except for areas. If you are missing an area, you would want to use your area ratio in a proportion. So when looking for area of similar figures. Okay? They ask also, how do I get the ratio of lengths from a ratio of areas? So we said to turn it from a ratio of lengths into area, we square it. So how would I go back to a length? Very good. So square root for this question. Square root the ratio of area. Alright, and then last one here, it says, when would I use the ratio of volumes? Well, again, when you're looking for volume in similar figures. And it asks, how would you get from a ratio of lengths, or get to a ratio of lengths from a ratio of volumes? So we said to turn it into volume, we cube it. So to go back, we would
do like the 3 and then the square root.
So it's called a cube root. Yes, that's exactly what we would do. So cube root the ratio of the volumes. And does everyone remember where that key is in their calculator? To do the cube root, remember you press math number 4. Okay? Math number 4 to take the cubed root of something. All right.